Hello, welcome to this fourth episode of Biotech Connect Webcast. This week we will have the thesis in 3 minutes from Benjamin Ralph from McGill University, and we will talk with Ryan Borgona from Nederman. Now, this is the time for the 3-minute thesis of Benjamin Ralph.
Aspergillus fumigatus is a filamentous fungus that is found everywhere in the environment. The fungus grows by forming long filaments known as hyphae and disseminates through the environment via airborne spores known as conidia. On a daily basis, we inhale hundreds of these spores without developing any clinically apparent disease. However, individuals with an immune deficiency or abnormal lung function are at high risk of generating one of two main forms of aspergillosis, that is, the invasive and non-invasive diseases. Half of my doctoral research focused on studying interleukin-1 receptor signaling during a non-invasive Aspergillus fumigatus infection, while the other half of my research focused on the immune response elicited by novel glycoconjugate vaccine against an invasive Aspergillus fumigatus infection. During the first half of my doctoral research, we found that IL-1 receptor signaling was important for maintaining neutrophil viability as well as function. This decreased neutrophil viability and function was also associated with increased susceptibility of the IL-1 receptor knockout mice to a non-invasive Aspergillus fumigatus infection compared to that of wild-type mice. The cytokine G-CSF has an established role for both maintaining neutrophil viability and function. When we supplemented IL-1 receptor knockout neutrophils with G-CSF, we found that we were able to restore the viability and function of these neutrophils. Furthermore, treating IL-1 receptor knockout mice with G-CSF restored their viability comparable to that of wild-type mice. In summary, the first half of my doctoral research established a novel role for IL-1 receptor signaling with regards to neutrophil biology and its role in a non-invasive Aspergillus fumigatus infection. The second half of my doctoral research was the development of a glycoconjugate vaccine against invasive Aspergillus fumigatus infections. The cell wall of Aspergillus fumigatus is composed of numerous polysaccharides. Some of these polysaccharides are Aspergillus fumigatus specific. One such polysaccharide is galactomannan. Galactomannan is composed of a mannose backbone with galactofuranose side chains. These galactofuranose side chains are antigenic, and we know they're antigenic because antibodies that have been raised against them are used in diagnostic kits in the clinic. Jointly with collaborators at the University of Alberta, we generated a glycoconjugate vaccine using these galactofuranose side chains. Mice vaccinated with this glycoconjugate generated high antibody titers against Aspergillus fumigatus, demonstrating that this vaccine elicited an immune response specific for the fungus. We also found that vaccinated mice were protected against an invasive Aspergillus fumigatus infection. For the shortness of time, I cannot get into it, but we believe that this was via an antibody-independent mechanism.
First, I would like to thank Ben Ralph from McGill University for sending us his 3-minute thesis. I got the time to send him a couple of questions, and he kindly answered to me. I first asked him what potential treatment to someone affected by this mold infection could be derived from your research. His answer: though my first aim was primarily basic research focused, we can get an appreciation for the importance of having proper neutrophil function. With that said, patients with an immune deficiency are at high risk of developing Aspergillus infections. Therefore, in some cases, it might be worthwhile to consider filgrastim, which is a recombinant G-CSF, as an adjunctive therapy to the antifungals. My second question was about the second aspect of second part of his PhD. Would you think that the second part of your research could lead to a vaccine that we could give to people susceptible to be infected by A. fumigatus? His answer: My work finished after early characterization of the immune response. Not to be overly optimistic, but I think there is some hope for our glycoconjugate with further studies optimizing the route, dose, and adjuvant for the vaccine. So that's interesting. This is another example where basic research is really close to clinical research. So thank you again, Benjamin. Good luck for the challenge and the gift card prize at the end of the month. And after this, we will start our interview with Ryan from Nederman. Today we are talking with Ryan Borgona from Nederman. Would you first explain to us what is your title in the company and what does it mean on a day-to-day basis?
My name is Ryan Borgona. I'm the Product Marketing Manager for Nederman North America. I've been with the company since 2011. As a product manager, what I do is look at technical specifications and engineering specs of our product and translate those to benefits to the customers. Nederman is a global company that specializes in clean air. We have an extensive line of products that are designed to keep workers from breathing in potentially harmful fumes and dusts. These products include extraction arms, vacuum systems, and dust collection systems, to name a few. Nederman is the clean air company.
One of the key products of Nederman that is interesting for laboratory labs are your collection of fume extraction arms. Can you give us some example in a life science laboratory where those arms are useful?
We have an extraction arm line in our product range referred to as the benchtop arms. The line is called the FX2 extraction arms, and there are 3 different types. There's the original, which is typically used in non-aggressive fume and dust extraction. There's the ESD, which is electrostatic dissipating, which would be used in environments where there may be concern with electrostatic discharge. Some of the examples of this arm would be used in soldering electronics or electronics repair. Finally, there's the chem, which is commonly used in applications that would need some form of chemical resistance. The extraction arm is typically used in chemical fume extraction, where the chemical being extracted may be corrosive or sensitive to contact with certain materials. The most common FX2 arms that we see used in hospitals or labs are either the original arm or the chemical version, or chem. Usually the applications in hospitals and educational institutions are non-aggressive, so in this case many applications would choose the original version. The chem model is usually chosen for its white color and stainless steel internal hardware construction. However, it does come at a higher price due to the upgrade in its hardware as well as in chemical resistant coating on the arm.
I was wondering, Brian, what are the requisites to be able to install those arms in a lab? Should these arms be plugged into the ventilation system of the institution? For example, the chemical hoods ventilation? Or they come with an autonomous ventilation system?
Generally, when installing any kind of extraction arm system, you should always make the system have its own duct system, filter and exhaust. The reason for this is that any system already in place was likely designed for the exact number of extraction points already on that system. This includes the fan and the duct design. In order to properly add extraction points to an existing system, that system already had to be designed in anticipation of growing the number of arms or hoods or extraction points that needed to be added. If you're to add an extraction arm to an existing system, there's a very high likelihood that there would be not enough air to properly extract the new additions. Or the new additions may cause other hoods in the system or other extraction points in the system to lose suction capacity and ultimately not work properly. Nederman FX2 arms, in comparison to other arms of the same style in the market, are designed in such a way that there is less resistance in the arm for the air to travel. This means that it takes less power from a fan to draw the same amount of air in our arms as it does to do the same with a competitor arm. In long term, This can result in energy efficiency and energy cost savings. In terms of airflow, on a 2-inch arm, FX2 or FX250 original or ESD draws about 50 CFM. Our 3-inch arm, the FX275 original Chem or ESD, draws around 100 CFM. Our 4-inch arm, FX2 original Chem or ESD, draws around 170 CFM. These numbers reflect a conveying velocity of 2,000 feet per minute, which is suitable for most smoke-like applications. The airflow can and will vary from one application to another depending on the type of fume or even the type of dust that you're extracting. One of the major benefits of the FX2 extraction arms is that we include the mini hood as a standard. This improves the airflow right out of the box. The mini hood allows the arm to draw more air from the front of the hood instead of pulling from the back. This keeps the air drawing at the fume source instead of away from the fume. We also have a selection of larger hoods, which would improve the air capture above the effectiveness of the mini hood. The combination hood and the dome hood and the metal hood are the most common we see sold in the market today. Adding these hoods to our extraction arms allows our arms to draw air from much larger working area and even further from the source when positioned against a working surface. This gives the worker a little bit more space to work with without the arm getting in the way.
Thank you for your explanation. Now I see how this can be useful for many different labs. How interested researchers should contact you if they want more information.
For more information on our products, please click the link below and provide us with some information, and we'll be able to work with you with your fume extraction needs. Or you can call us at 1-866-332-2611 and we'll get you in touch with your local Nederman expert. For more information on this and many of our other fume extraction products, please visit us at nederman.com.
Thank you very much, Ryan. And that will be all for this week's episode of Biotech Connect Webcast. Thank you very much for everybody that is participating in our 3-minute thesis contest. This is not finished yet. If you are interested, just go on biotechconnect.ca/3mt as 3-minute thesis. So biotechconnect.ca/3mt to get more information, to participate. And don't forget that if you want to vote for this 3-minute thesis, you just need to specifically share and comment on the post where the thesis is posted. Thank you so much for your participation and see you next week for a new episode.